name is Vui Nguyen, and I'm here to present the Wildfire AIM project, which was developed for the Microsoft AI Innovation Challenge in June of 2025. So I'll start by introducing the team that built this project, the challenge that we were tasked to solve, our problem statement, our solution, some of our key learnings, and future development. So the team is myself, Vui Nguyen. I was the AI Solutions Architect, and I had the pleasure of working with Reka Vanabalan, who is our AI engineer. So the challenge we were tasked with solving is with wildfire resilience. So how can we use AI to help emergency responders, planners, and policymakers mitigate the dangers of wildfires? Our problem statement is that there's too much data out there on wildfire management. And for those in charge of implementing wildfire prevention and mitigation, such as fire agencies, the Bureau of Land Management, and so forth, how can they sift through all that data and develop an actionable plan? And how can AI be used to help solve this problem? So the solution we came up with was a RAG search chat application. We focused on prescribed burning as a wildfire prevention and mitigation method as practiced by the Karuk tribe of Northern California. We want to provide culturally sensitive guidelines for U.S. agencies to expand the use of prescribed burning in cooperation with Native tribes. And we saw possible users of this application to be the Bureau of Land Management, fire agencies, Forest Service, and other agencies. So let me give a demo of our project. So let me start by inputting a first question. Now, as you can see, the answer generated is grounded in the data sources that we fed to the AI model chat previously. So now let me demonstrate with another question. And as you can see here, the answer generated is culturally sensitive and encourages cooperation between U.S. agencies and Native tribes. So here are the screenshots of the application that I demonstrated previously. So how the architecture of our system works is that the user would input a question into the web portal, and then that gets sent to the Azure AI search, which will then search for the answer in an index that was created from the data sources that we had fed to our system previously. Then that data from our index search is returned to the app, which then forwards it to the Azure OpenAI chat, which will generate a response and display it back to the web portal. So the Azure services that were used are Azure OpenAI, Azure AI Search, and Azure Storage. Our tech stack is we use Python and Bootstrap on our front end, and Python and Flask on the back end. And as for the Azure AI back end, that was already configured through the Azure portal. We did run into some challenges while implementing this system. One big one was we kept hitting the API rate limits when calling the OpenAI endpoint to generate our response. So we tried a couple of solutions. One was load balancing, which load balancing the endpoint, which didn't work out very well. We also tried to request an increase in our quota, so we don't hit those rate limits, but we found out we had to request the increase in advance, and we were running out of time for the hackathon. We also tried a couple of other ideas. So we found out that we could search the index directly in the index playground, but one downside to that is it didn't give us the full quality answer from the index search and the OpenAI chat together. We could also just input our questions into the OpenAI chat directly, but again, that also had the problem of not getting us the full quality answer from the index and OpenAI chat together. So the final workaround that we chose was we decided to go with the index search answers, and then we hard-coded those answers into the web front end. And we decided that this was the best solution because even though we're missing out on the addition of the OpenAI chat in our generated response, but still the index chat allowed us to have our responses be grounded in our data in order to control the quality and improve the chat narrative. Some of our key learnings is it is important to find balance between spreading the benefits of prescribed burning as a wildfire prevention method with cultural sensitivity. So we're not culturally appropriating native tribes' traditions. Also, for proof of concept, narrowing the scope is really important. And we chose to focus on one method of wildfire prevention, which is prescribed burning, and dive deeper into its cultural importance to the Karuk tribe. And with time running out on our project, we really needed to focus on what we can get done, implement workarounds as needed, and then we can put the rest into the future roadmap. We also had to address principles of responsible AI. And since this is a new project, we've only started on our responsible AI journey, but here are some of the ways that the Wildfire AIM project is implementing those principles. So by focusing on recommending the use of prescribed burning in culturally sensitive ways, that's how we implement fairness and inclusiveness in our system. Also, the data sources that we use to ground our RAG responses are documented in our GitHub repo for transparency. Unfortunately, our system is not handling any sensitive user data, which is good, and any API keys that we use to access the AI backend are stored securely and away from the public code. And also, continued testing during development will ensure continued quality of our system, which will help with reliability and safety and accountability. And as we mentioned, there were a few things we would like to complete in future development. One is to fix the API rate limiting problem so that the application can actually work fully end-to-end without any workarounds. And as it is right now, the application is a one-shot search application, but we would love to eventually change that to a multi-turn chat. And that's our presentation. Thank you for watching. For any questions, you can contact myself or Vui or Reka. There's our GitHub profiles, or take a look at our source code at the link there. Thank you so much.